Welcome to lecture 35, bow tie quantification part 4, probabilistic approach using Monte Carlo simulation. This is under risk quantification for the subject safety and risk analytics. We will discuss bow tie quantification, particularly using Monte Carlo simulation, how the accident paths what we have discussed in previous lecture from the bow tie can be quantified, as well as what does it mean by the accident scenario quantification. So, these aspects will be discussed, and we are primarily discussing on the probability of the accident paths in the bow tie as well as probability of accident scenarios. From risk quantification point of view, there is another issue which is known as consequence. That consequence part we have not yet considered. We have just considered the probability of different accident scenarios in terms of that end state in the bow tie, or in terms of different accident paths which are basically combination of basic events in the bow tie. So, what is basically that probabilistic approach that we want to discuss? When we say that probability of a basic event B1 is 0.5 or 0.3 or 0.02 or 2 into 10 to the power minus 5. So, these are basically point estimation, that means one value for the probability. But you know that every event occurrence is subjected to many random causes, and as a result a particular point value about the probability of a basic event may not be practically possible, practically I can say interpretable as well as useful all the times. It may so happen that that particular probability value also vary along certain range. So, in order we require to identify that range. If you identify that the point estimate of the probability of basic event occurrence, in addition you can say that this probability can vary from maybe certain range to another range, some kind of interval if you can find out, and then that is basically more appropriate in the sense that you are giving a range of values for a particular event probability. That is the approach that is probabilistic, I can say that probability estimation. Probability, if I consider probability of a basic event is a random event or as a random variable, then what is the distribution of probability of a basic event, then that will be called probability distribution of the basic event probability. Okay, so probability distribution of probability, that you please keep in mind. So, it is something more, that means probability. That is why sometimes when you talk about probabilistic risk assessment, people say risk equal to P cross C, where the probability of event and the consequence of that event. So, if one probability is there, then what is probabilistic risk assessment? That means if we consider this probability, all parameter also follows a distribution, and then what will happen? The risk value will not be a point value, it will be also a probability distribution. So, that means risk also will follow a distribution. Similarly, if you find out that consequence also follow certain distribution, then the probability distribution times consequent distribution, that also give you risk distribution. So, consequence can be deterministic, can be probabilistic, but it is mostly probabilistic in nature. Okay, so in the future lectures definitely we will talk about risk distribution also, but in today's lecture we are basically talking about only the probability of basic event, that is one, and the distribution of basic event probability. Second, knowing the basic event probability distribution given the bow tie, what will be the like the accident scenario distribution from probability point of view, probability distribution of accident scenarios, as well as we have seen that an accident scenario can compose of many accidents path using the Cartset's method we have discussed in previous lecture. So, that means for each of the accident paths in the bow tie, what could be the probability distribution of the probability of those accidents path occurring, each of the accident path occurring. So, this thing we will be discussed in this lecture. Very important lecture in the sense that this will talk about some kind of uncertainty quantification also in terms of the estimated probability values. Now, see, when you talk about accident paths, I think you can relate now with my previous lecture. There we have generated 4 accident scenarios, AS1 to AS4, and again even in AS1 there are 4 accident paths, and in AS4 8 accident path that change. So, it is a general, suppose there are many accidents paths, and then you know what is the probability of occurrence of AP1, AP2, suppose this is almost 0.9, then this one 0.8, these probability values are again hypothetical values. So, but in real life situation you have to compute this value, that may not be this high, but the probability values will be there. So, when you talk like this is basically point estimate. But what is the guarantee that suppose if I consider AP2 whose probability of occurrence you are saying suppose 0.78, what is the guarantee that it is 0.78? It can be 0.78 can be something average, and it can vary from some maybe 0.5 to maybe 0.9. So, this kind of interval is important, and this kind of interval estimation in the cumulative side we will basically consider in terms of cumulative distributions. For example, here I have given one path, but not these probabilities are that high. I have considered some more realistic sense the probability value is 2.5 into the minus 4, and then here suppose it is almost 4.9 into the minus 5. So, this is the range from these two, suppose this is the range, and what is the that when a probability that the probability of an accident path will be suppose at 10 to the power minus 4 or less. So, that you want to capture, then this is the issue. So, how to interpret this CDF of the for the probability of accident path, or for the probability of basic events, or for the probability of accident scenario. So, only thing is that the x axis will become the probability value for the basic event, or for the accident path, or for the accident scenario, and y axis will be the cumulative density, that CDF, cumulative density function. This will gives you basically the probability value. How it will give you? Suppose I want to know what is the probability that a particular accident path the probability of occurring of a particular accident path 1 into 10 to the power minus 4 or less, then from here you can get. Okay, so you just draw a vertical line, it will meet here, then draw another horizontal line, it will be here. So, that means the probability value 10 to the power minus 4 or less, it is almost 0.9. Okay, so the probability value will be this, or less will be 9. Suppose if I want to say that okay, what is the probability that it will be 5 into 10 to the power minus 5 or less, it will be something like this 0.19. So, this kind of information you will get when you are going for finding out the distribution of the probability of a basic event, or of an accident path, or of an accident scenario. depending on your interest. But if it is an accident path, if it is for a basic event, then we have given you earlier that the basic event probability distributions from the manufacturer handbook, from historical data, from experts opinion, how to compute this. Then we have also given you the bow tie, and we have shown you the approaches how to quantify the for the fault tree the top event probability distribution, as well as for the pivotal events probability distribution, and then finally the accident scenario probability distribution, as well as accident paths for different scenarios distribution. That approach we have discussed. But from the quantification point of view, the probabilistic approach using Monte Carlo simulation we have not discussed today. That is what I am discussing. And if you want to learn more about this Monte Carlo simulation and related things, so we have a publication along with my scholar Arun Raj in 2013 in Accident Analysis and Prevention, that basically uncertainty in risk analysis using that Monte Carlo simulation and two-dimensional FMCA, that is two-dimensional fuzzy Monte Carlo simulation. So that paper you can go through. In addition, a couple of paper along with Arun Raj we have published in Journal of Hazardous Materials. So those things papers also very useful for all of you. You may go through all those papers. So now I will go to the basically approach. Here we will discuss only the probabilistic approach. So I am not discussing the fuzzy based or and other approaches. Only the probabilistic approach we will be considering. So if you want to use it, then what is the information you require to know? Your inputs will be basically probability distribution of basic events. In the bow tie, you have seen that if you know all the basic events and their probability, you are in a position to quantify the initiating event probability as well as accident scenarios probabilities and other things I have discussed. I am repeating the thing just to make you understand that when it should go to your mind. That sense I am repeating most of the times. So once you know the basic event probabilities, the distribution, then the using Cartset method I have shown you that how the quantification is possible, and then using Monte Carlo simulation, which is basically a repeated random sampling method, how the distribution of the suppose the top event for the fault tree and probability distribution for pivotal events and probability distribution for accident scenarios, similarly probability distributions for probability of that I can say that accident paths, all those things will be outputs. So few outputs we have given. Now how Monte Carlo simulation works, what are the basic premises for Monte Carlo simulation? Monte Carlo simulation assume that model parameters are random variable, crux of the matter. Please keep in mind this one. Okay. So model parameters are random variable, so which can be represented by probability distribution. Now the calculation of an accident path probability in a bow tie is performed using large number of iterations, and it is based on repeated random sampling. So I already told you these terminologies. So I hope that you will be able to appreciate it, and if you have any problem related to understanding Monte Carlo simulation, you can go through any book. There are many books and videos available on Monte Carlo simulation. Whatever needed for this subject I am just discussing. So now if I want to use Monte Carlo simulation, how can I use here? There are the first if you use get by get method for the fault tree, and that also can be used. For example, let the probability of basic events, these distributions are given. So, these are definitely cumulative CDF functions are given. So, if I know B1 and B2 the distribution, so using Monte Carlo simulation you will be able to, means you will sample repeatedly from this and from this B1 and B2 distribution, and then what you will do using the OR function, the IE value, this has relation between, so probability of IE1 has a relation, that probability of B1 plus probability of B2 minus probability of B1 into probability of B2. So, if I do repeated sampling, I take one value for probability of B1, another probability of B2, I put here. So, my first iteration I will get probability of B1. This I will continue maybe 1000 times, 10,000 times. So, then you will be getting a distribution for probability of IE1, which is this. Same manner you will be using a distribution for IE2. Now, once the distribution of IE1 and IE2 are known, probability distribution, then top event probability, again you can go for by using this method, that okay, it is AND gate. So, as it AND gate, then probability of top event PE will be probability of IE1 into probability of IE2. So, using AND gate. So, again one more Monte Carlo simulation if you do in the same manner, you can get this one. Okay. And then after that you come to the event tree path, and in the same manner multiplication using repeated I can say drawing of the some probabilities and multiplying with the appropriate, using the appropriate formula, you will be able to get AS1, what is the accident scenario for this, accident scenario for this, scenario for this, these distributions you will be able to generate. So, repeatedly, first of all in every step repeated random sample, and you are basically repeating the Monte Carlo simulation approach at different nodes. Here all the gates are nodes in fault tree, and here also the PB1, PB2, these are the nodes are there. So, you have to do it. So, this is a one approach, that first find out intermediate probability distribution and then top event probability distribution. So, one top event probability distribution, that for a particular I can say event tree branch, again you do accordingly. So, this is one approach, and another approach could be just you know the cut set, because you know what is the cut set for the top event, and at the same time we have discussed earlier that pivotal event cut sets, and then finally we created the accident scenario cut sets, and then all the cut sets, every cut sets for a scenario is an accident path that we discussed. And that means what will happen, instead of going from that the stage wise, that first the basic event followed by intermediate event followed by top event followed by PV1, PV2 like this, you can also use the other approach. Other approach is what? I know the cut sets, I will just consider that the basic event, that probability distributions everywhere, basic event probability distributions here. So, here also some distribution will be there for everything, this distribution will be there like this will be there. Now, I know the cut sets. So, once I know the cut set of top event, cut set of pivotal events, I can generate cut set for accident scenario 1, cut set for accident scenario 2, accident scenario 4 like this. Last lecture we have discussed this. So, depending on the nature of the cut sets, so again you just repeatedly draw samples from each of the basic event distribution, and using the formula find out what will be the probability distribution for the accident path for that particular accident scenario. So, every cut set one path. So, that sense you find out and finally add up to the accident scenarios. If there are 4 paths in a particular accident scenario, each of the probability in the iteration you add up, get the sum one, and that will be the scenario probability distribution for scenarios. Okay. So, this approach we will discuss. The approach what we are presenting here, it is one of many ways to do it, but using Monte Carlo simulation, this is the approach we are basically using. This approach, the second one I am going to show, first one also you can do, but as you have the option for generating large number of iterations and large number of data. So, I am sure that there will be less difference whether I will go this approach or the previous approach from the overall accident scenario probability the generation point of view, unless there is dependent structure. So, now see we will discuss here, okay, this is not no need of discussion, this is the repeat one what I have discussed in previous one from the path concept. Let me repeat here, path concept is nothing but the combination of basic events which ultimately lead to that particular scenario. For example, we have discussed earlier that for scenario 4, for this scenario there are 8 accident paths, means 8 different combination of the basic events B1 to B10 that lead to accident scenario 4. So, this is a repetition, but it requires to know before going to the next slide. Now, let us consider that we have probability distribution for each of the basic events. We have computed it based on the information or the distribution parameters, distribution as well as parameters are known. Now, then what happened for every basic events, the CDF is generated for a large number of that CDF values. Actually, these values are created here. So, I have now the B1 to B10 that distribution I have. So, this is the input in the process model for quantification what I have shown, this is the input. Now, the CDF plots for B1 to B10, you just see that this one we consider everything in days. Basically, we are saying that okay, certain days the time to failure point of view, we have considered time to failure point of view. Suppose 100 days, what is the, suppose if I consider here 50 days, what is the probability that B1 work for 50 days, within a span of 50 days, what is the probability that B1 fails? So, then you can say it is around 0.4. That is the way you have to understand these distributions. So, for all the data what I have given in the previous slide, the table, this is nothing but the table pictorial representation. So, hope that you have this kind of information with you, and that is the input. Then let us see that how we will do the Monte Carlo simulation. A simplified flowchart for Monte Carlo simulation we have used here, and that is for the purpose of computation point of view. And here suppose basically as we require to know basically the generate, here I can say as we are interested to generate that accident paths probability or accident scenario probability. So, let us discuss only on the accident path probability here. So, we have data now, input basic event inputs are there. What is the input? What is the distribution and its parameters, suppose if it is known. Then using you can derive the CDF of BI. So, let n equal to the first iteration, select random values of that BI event, So first work is you generate the random values for the basic event, because you know that you have the CDF. From the CDF, select a random values from the CDF. Now, is there any basic event left? If it is not, you take the next one. If it is yes, you take the next one. If it is no, then compute the probability of accident path. Okay. So here I can tell you that some more steps are omitted in between, but because when you are talking about accident paths, here the probability, when you compute, you have to use the probability, that path probability computation approach what we have given earlier, considering the BI, means basic event probability. So from every basic event which are responsible for that path, so from that CDF you just randomly you select 1 1 1 1 1 and then use the formula, get the probability of the accident path, iterate for the, go for the next iteration, do it, go for the next iteration, do it. In this way the things will continue. Okay. So suppose the number of iteration, basically you are thinking that it should be 500 iteration you want to do. So if it is less than 500, so then you continue this. Okay. So you just see that what happen, n equal to first 1, select random values for the BI, then compute, then is there any other, so you just find out for this accident path how many basic events are required, and then for each of the such basic events, that random value you have to pick up, that probability value, and then using the formula you have to find out the probability of the accident path. Now then again what will happen, after this you have another one, that this first iteration, second iteration, third iteration. So you are asking that whether all the iterations are, required number of iterations are over or not. If it is not over, then you basically what you do, n is less than this, then if it is yes, you are actually what you are doing, you are incrementing it and then you are calculating it. So now see that this is the loop. Only thing is that, as I told you, that few more steps could have been added here, but it is not done. So you have to, you know the approach, so you have to add it. So once the required iteration is complete, so is n less than equal to this, if it is no, that means n is 500. So then you have basically 500 values. Now 500 values, from the 500 values what you do, so these 500 values you just create, so ascending order you create, so minimum to maximum, and then create certain bins from histogram point, drawing histogram point of view, some kind of bounds you just create or bins you create, and you see that in each of the bins what is the frequency, how many things are there. Okay. So how many times that within these bins how many iterations or observation falls, and then from there you just find out the cumulative one, and then obviously if you know the bins, number of bins, suppose bin 1, 2, suppose k number of bins, how many falls, suppose f1, f2, like fn, then the cumulative value will be f1, f1 plus f2, like this, sum of fi ar I equal to 1 to k. Okay. So then if you want cumulative probability, just you divide this c by total sum of fi I equal to 1 to k. So that will give you the probability distribution, cumulative probability distribution. So that way you can find out. Fine. Now we will go for the approach. So we have computational approach B1 to B10, and depending on, suppose we are quantifying AP1, accident path 1, Suppose accident path 1 basically comprises of few of the basic events. So, for those from those basic events randomly picked up, and you will get using the required formula, you will be, because the formula I have given you in earlier lectures. So, you will be getting all those values. In this manner you will continue. So, once you have that accident path probabilities, then you can go for quantifying the I can say drawing the cumulative distribution. Now, you understand this for AP1. So, these are the values. Now, AP1 is basically we are saying accident path 1. So, what is the probability of accident path 1 occurring? So, the x axis talks about the probability values, that is the probability 0.9 or less, 0.12 or less, or something like this. What y axis we are saying that okay, the probability will be 0.9 or less, so it is almost 0.7. So, that sense the cumulative the distribution for the probability of the accident path, the way cumulative distribution for the probability of the basic events we discussed, the same way it is to be understood. Okay. Now, here we have given you all the 8 accident paths which are basically part of accident scenario 4, means each of the path lead to accident scenario 4. This we got from the bow tie. So, our probability of accident scenario 4 particularly for the each of the paths point of view, it is now like this. Now, as if I want to tell what is the probability distribution of accident scenario 4 in terms of probability of accident scenario 4 happening or occurring, then obviously what will happen here, because all the paths are possible. So, if you can, what we actually have done, we just concentrated on that the total one, where we are saying that accident scenario 4, we just add up all the probabilities AP1, AP2 up to AP8 probabilities. So, that adding this one you got. So, now you that whether adding is perfectly all right or not from the statistical sense, that is the different issue, but more or less what we understand, as these 8 OH accident scenarios can take place, and as there are so many iterations, so much of probability values for each of the paths, adding them basically we are trying to get the AS4. So, I hope that will also perfectly work. So, that is what is our assumption I can say. So, then the AS4, that probability distribution of probability of accident scenario 4 occurring is given here. Okay. So, that is what we are saying, that accident path quantification and accident scenario quantification using probabilistic approach with the help of Monte Carlo simulation. Okay. So, I hope that you got certain ideas that how the things are happening here. So, what are the things we discussed so far? We first discussed that Monte Carlo simulation, which is basically a repeated sampling method, and we assumed 2 different ways for bow tie quantification. One way is that suppose let use the gate by gate method and the Monte Carlo that repeated sampling approach, and intermediate gates you that quantify the probability, and then finally top event probability distribution you quantify, and then go to the event tree branches and do it. That example we have not shown here. We have then what we have seen, that okay, we found out the cutoff for the card sets for each of the accident scenarios, and we from the how many card sets are there, considering the number of card sets, where each card sets is combination of the basic events. So, that number of card sets will give you the number of paths. Then knowing the basic event probability distribution, so the probability distribution of the accident path probability also computed, and I have shown you the CDF, and then finally if I combine all the paths related to a particular scenario, that will give the probability distribution of the probability of that particular accident path. So, probabilistically we have basically considered everything, and probability distribution we got. Here the issue is that you are not only getting a probability value, you can get the mean of the probabilities, that average probability. You can also, you are getting a range, you can concentrate on the standard deviation of it, then uncertainty. Now, okay, probability this 0.5, but with certain standard deviation, that also you can compute. And the CDF approach is giving you okay that what means some kind of further insights also can be drawn from this. But if you say accident risk quantification, then this is not sufficient. This is basically one part of risk we have basically discussed so far. In all the 5 lectures so far in this particular week, I have discussed only the probability quantification point of view. So, if I want to bring the risk quantification, then please keep in mind we have used several approaches for this quantification, 2 parameter approach, then we have used 3 parameter approach, probability consequence detectability, then R equal to probability consequence exposure, so many things we basically consider. Now, if we go for point estimate, then suppose P equal to 0.03 and C let it is 10,000 rupees, 10,000, suppose C rupees 10,000, then R will be 10,000 in 2.03, so that means 30,000 if I write, but it will be minus the 2 decimals, so it is basically 300. So, the risk value is 300, as probability is dimensionless, so this is rupees 300, that kind of things you can say. So, it is difficult to get consequence in terms of rupees most of the time. So, we will use certain index for your consequence point of view also. Similarly, if you consider D, then again the point estimation point of all value will be and the risk will be computed. But what we have shown in this lecture in the probabilistic approach, we have shown like this, that this is a distribution, this is some kind of distribution, that P. Now, what is C? Consequence. Consequence is deterministic or probabilistic. If consequence is deterministic, so that means that particular value will be used here. Consequence, if it is not varying, if that particular path or the scenario takes place, then the consequence is a constant value, then only the risk will govern by the probability distributions of the probability of the event occurring. But if the consequence distribution is also there, so then another distribution will come. So, now if your risk distribution also will be that multiplication of these two, and that also I have discussed in some of the earlier classes. So, you please understand that that is what is risk quantification in terms of probabilistic risk assessment. Anyhow, we definitely discuss little more about this risk quantification, and some of the papers I have already discussed with you. In fact, although I have mentioned here these two as well as my previous that NPTEL course, but I want to mention another paper that you go through Arun Raj, NS and Maiti J. So that paper, one paper is I think in 2013, that uncertainty in risk assessment. Then a couple of other papers in Journal of Hazardous Materials. So I think in 2009 and 2010 we published some papers. This will be important. Okay. So now what I will do, so I will close the session now. Thank you for your patience and kind listening to my lecture. Hope you find it meaningful. Thank you very much.